Okay, so we are going to get started. It is 3:30. These sessions run from 3:30 to 4. They are half-hour sessions, and we just did our warm-up. A lot of you had an opportunity to practice, so that was great. And we are now going to get started. Libby, I see your hands up. Yes, do you have a question? I thought we were going to start through. Well, that's actually one thing. Once you bring that up, why don't we vote on that right now? It has been brought to our attention for some teachers it's difficult to get on at 3:30. If you would prefer to keep it at 3:30, put in a happy face. And you'll see these icons right below where it lists participants. So if you'd like to keep it at 3:30, put a happy face. So it looks like one would like to keep it at 3:30. 2, 3. Okay. Susan, 4. 1, 2. No, 3 still. Pat, 3:30 is best. Mr. Diaz, I'm neutral. Diana, I'm not seeing the icons. Okay. Diana, if you look under on the left-hand side of your screen, you'll see where it says participants. And underneath that, you'll see like where you could raise a hand. It has a hand with an arrow up. It has a happy face and a sad face, and then a hand that it's supposed to be clapping. It has this little like thing, or a thumbs down. Do you see that now, Diana? Oh, you want to keep it at 3:30. Okay. Seems like the majority want to keep it at 3:30. So what we might end up doing, we had discussed this in the office of perhaps changing it to 3:45 for second semester, but I guess we could revisit it at that point. Libby, I see your hand still up. Did you still have a question, or is it just because I didn't take your hand away? Okay. So we're going to keep it at 3:30. So do your best to get on, and we try to start on time as well. So we'll keep it at 3:30. I'm just trying to see. It doesn't look like we had anyone else new join us. I am here right now by myself. Helen is going to be joining me momentarily. So if you type something in the chat box, what I prefer if you could do is see the hand with the green arrow pointing up. That's how you raise your hand. And so since it seems like nobody has a mic, type your question first in that chat box and then raise your hand, and I'll call on you, and then I'll get your answer or your question right away, and I'll answer you via voice. All right, so we are going to get started. Today is on area multiplication. It's on lesson 1.1 actually in the student weeks. So it is the first week and one of the first lessons. For those of you who've taught our program before, you will see the area model comes up more than with just whole numbers. It'll come up again with fractions and with decimals. And what we are going to do is, I just wanted to type out a problem for you, but if I have something like this as my question or my problem, but the problem is I'm a kid who doesn't know my 7s or I don't know my 8s. There's different things that kids could do, and especially when students are younger, meaning first and second and third grade, teachers often in elementary school count on using prior knowledge. And as kids get older, we tend not to call so much on prior knowledge because we assume they'll call on prior knowledge, but they don't necessarily know to think of calling on prior knowledge. And so one of the things that could always work is, okay, I don't know 7 times 8, but I know my 2's, so I could do 2 times 8, and I also know my 5's, so I could do 5 times 8, and from that, I could still get my answer because I will still know, oops, look at that. I just did it too high. 2 times 8 is 16, and I know that 5 times 8 is 40, and I could just add those two together, and I know that 7 times 8 will give me 56. So one of the things that we have in there is a page called derived facts, meaning, things that you get from somewhere else, but I like to also call it prior knowledge. And there's nothing wrong with doing this. Of course, it takes longer. However, the more they do it, they'll also eventually remember, oh, that's right, 7 times 8 is 56. I should remember that by now. And the reason why I point that out to you is because we're going to be looking at different things today, such as our goals. And our goals today are using logical reasoning to derive multiplication facts, such as the example I just showed you. If I have the ability to know that 7 is 5 plus 2, then, and if I have any understanding of properties I could know that I can multiply 8 times 2 and 8 times 5 and add those two products together to get my answer. We're also going to look at the commutative, associative, and distributive properties, which allow us to pull numbers apart and use them like that. And we're going to compare it to the traditional algorithm. So those are kind of the goals for today. So the first problem that we worked on when we split it apart like that, who could tell me which property you think that I was exhibiting when I split my 7 apart into a 2 and a 5 to answer 7 times 8? Anyone like to raise their hand or type it in the chat box what property they think that might have shown? Distributed, very good. Pat, what do you think? Susan says distributive. Pat, do you have a question? Diana says distributive. Pat, do you have a question? You could just type yes or no in the chat box or type your question in the chat box. I'm going to assume maybe not. Mr. Diaz, did you have a question? Or you just wanted me to see your answer down there? No, okay. And you're correct. It would be the distributive property because what I did is I distributed it, I broke it down and then distributed my 8 across to the 2 and to the 5, which is the same thing as multiplying 8 times 7. So this is one of the pages actually out of the packet. It is on SP2, and if you have it in front of you, you could see that for yourself. And it's just something that I know a lot of teachers think, my kids are having trouble and difficulty remembering so much of math. How can I possibly go into all these properties? It's really helpful for kids to understand how numbers work together and not to be afraid of pulling numbers apart and putting them back together and just having that fluidity with their number sense. So I just wanted to point that out, that was in there, and it is something that you will see continually throughout the program again, that we will talk about the distributive property again, we'll talk about the commutative property again and such. And somebody's answering my question for me. I believe it might be Pat typing. So, is that the distributive? I just have a question on that. Nope, somebody erased their answer. Which property do you think is shown on problem number 1 now that we saw that come across? Right, it would be the associative. It doesn't matter, as I always just tell my kids, who I associate with. As long as I associate with everybody, then it works in multiplication and addition. Okay, when you have any questions, please just raise your hand because I always feel like I'm talking into space, so feel free to raise your hand. The reason why we look at multiplication differently in this unit is because multiplication is usually when you ask teachers, starting probably anywhere from about 4th grade on up through even high school, what is a difficult task for your students? And a lot of them will say because they're not fluid in multiplication. And because of that, it's causing a significant barrier in other math performance. So that's why we want to try to provide you with other strategies, such as looking at prior knowledge. I also wanted to show you base 10 blocks. I'm quite sure that most of you are familiar with them, though unfortunately we don't tend to use them as much in middle school as they do in elementary school. And it's a fabulous tool, and if you don't have any, you may either want to get some or you may want to borrow some from your elementary district, because I guarantee you they probably have cupboards full of them that are seldom being used. But there's a 1 square that represents a 1, and then there's 10 of those little 1 squares that are actually stuck together on a stick that represent 10, and sometimes they have those separate lines and sometimes they don't. And that's why I showed you both ways, because sometimes, like I said, it has all the little lines and sometimes it doesn't. For kids who are trying to figure this out and understand, those little lines help a lot. And those, the only reason why I did them, they're in yellow and blue because we are UCLA, but those 10 ones with the dividers in it like that do tend to be in yellow. And then there's the big square, which is the 100 square, because it's a 10 by 10 square. And we try to get kids to also realize that if this is 10 and this side's 10, then 10 times 10 gives me 100, and that's my area of this and what all those little squares are. So instead of me having to literally count 1, 2, 3, 4, 5 all the way up to 10, I know that that's 100 squares. So I showed you a plain one of both of those. Then I showed you how you'd represent a number, let's say 14. We have a 10 plus 4 little ones, or a 10 plus 4 little ones. How would I represent 132? I'd have my big 100 plus 3 10 squares plus 2 little 1 squares. And look at that beautiful little square that made for me. So I just wanted to make you aware that those are out there. And when we talk about the area model, we like kids to be aware of 10 blocks, and a lot of them have done that as well. Oh, hello, Helen. Welcome back. Did you get, oh, it looks like we have a new person on, so hopefully that's who Helen helped on. Welcome. Helen, while I'm talking, if you could keep track of the chat box in case if I miss something, a question coming through, I'd appreciate it. Thank you. Helen works in the office with me also, so she's going to help me out keeping track if you're chatting while I'm trying to go through because it's hard to answer. Okay, so that's what 100 blocks look like. Is everyone familiar with them? If so, give me a happy face. If not, give me a sad face. Oh, good. It looks like everyone's familiar with them. Perfect. Can you give me a happy face if you actually have them in your classroom? Oh, most of you have them. Fabulous. Oh, Mr. Diaz doesn't. Okay, but most of you have them. That's fabulous, because they really are a valid and helpful way to talk about multiplication. Okay, moving on. The way that we use area multiplication is when we have a problem. I'm actually looking here at problem number 4, and it's 3 times 14. Well, one way that we start is if I have, once again, representing like with those base 10 blocks, if I have 14 going across and I have 3 down, well, I could count up all those squares to find out what's in my area, but what would be easiest is to multiply it. But if I don't necessarily know my 14 facts, which quite a few kids probably don't, I could still say, because we learned with the distributive property a few minutes ago, that I could say, well, 10 times 3 and 3 times 4, and I could get an answer from that, because I could say, well, 10 times 3 is 30, and 3 times 4, sorry, is 12, and hence I could add that together and get my answer if I don't originally know what 14 times 3 is. So who would like to practice, who practiced on our warm-up earlier, on actually filling in what this little equation right here would look like from the information above? Would someone like to raise their hand and give that a whirl? Okay, Helen, go ahead. Very good. Very nicely done. Pat, did you have a question? Or were you volunteering to do that as well? Okay, perfect. Thank you. And now it's flipping back and forth between a 1 and a happy face. All right. So if I have, this would be a representation then of the area model for me. And I could have even, let's say, I mean, everybody knows their 10 facts, but let's say some kids don't. I mean, I could have put 5 plus 5 plus 4. I could have put, 10 plus 2 plus 2 and divided it up even further. And either way, I'd still get my answer. Yes, Harvey, your camera came on. I turned you off, though, but others are saying you could smile because your camera's on. Up along the top icon bar, you could turn your camera on or off if you have a camera on your computer. But I'm not showing myself on a video right now, so if you're looking for me, you're not going to see me. Okie dokie. Any questions with this area example right here that we just did? If you have a question, can you raise your hand? And if you don't, just give me a thumbs up and we'll move on. Oh, someone's clapping. That's also good. I'm going to assume. Okay. All right. It doesn't look like we have any questions, so I'm going to continue to move on. If we have, so what I did is I took an example similar to what we just did, and I showed you the traditional algorithm of how we work it out. So I have my little finger pointed over actually to the right. And in a traditional algorithm, you would say, well, 8 times 9 is 72. I put my 2 down. I carry my 7. And then most teachers would say 8 times 3 is 24, plus 7 is 31, and write in 31. Not necessarily accurate in the wording of how you would do it. And then some teachers for this 0 here would put an X, and some teachers say you could do either. And the reason why is because you're moving 1 over, so you move 1 over. And they say, well, 1 times 9, and then 1 times 3, and 1 times 9 is 9, 1 times 3 is 3, and then you just add it up. When in reality, you've just multiplied 8 times 39 in that row and 10 times 39 in the next row. But if you look at partial products, which is what the area model more represents, I'm actually saying, well, 8 times 9 is 72, and 8 times 30, because this 30 is in the tens place value, 8 times 30 is 240. And then I don't need to worry about holding a spot because I'm keeping my place value. 10 times 9 is 90, and 10 times 30 is 300, and then add up all the partial products. So if I did that in an area model, I'm going to actually see if I could pull this off right this second. You could see how skilled I am at this. It's probably not very skilled, but that's okay. So look at that beautiful square I just drew. And let's say I put, oh, thank you, whoever's typing that in. I believe that's Helen that's helping me out there. So she's showing how the area model would actually work. And the 300 that she just did is our 10 times 30, which actually is this bottom fact right here. And then she did 10 times 9, which is 90. 8 times 3, which is 240, and 8 times 9, which is 72. And if you look at 72 plus 240, you actually get the 312 that's over here. And if you look at 300 plus 90, you get the 390 that's over here. So it's really important for your kids to see, because a lot of this traditional algorithm, A, it isn't worded correctly when we do it, and B, it doesn't make a lot of sense to kids. But when they see partial products like this, or when they see it based in an area model where they could actually have room to write it out, it tends to make more sense. And then a lot of times they realize through this they could get to the traditional and carry on. So any questions about partial products, area model, relating it to the traditional algorithm? If you have a question, raise your hand. If not, give me a happy face and we'll keep on moving. Oh, look at all those happy faces. If you're actually, is anybody brand new to the program? If you're brand new to the program, can you give me a happy face? Oh, good. Oh, one person. Okay. Otherwise, everybody has taught it before. 2 people are brand new. But Pat, you're working with somebody in the room right now, I think with Catherine. So hopefully that's working out well for you. Okay, so we're going to keep on moving. I put up a problem here of 13 times 14. Who would like to raise their hand? And I'm going to have you each either do, if you want to do, I'd like you to do an area model and then relate it to the traditional algorithm, or an area model and relate it to the partial products. So who would like to take this square here? Raise your hand. Hold on, let me see whose hand that is if my screen's not big enough to see. Okay, Mr. Diaz, you could do this square on the top left. Who else would like to do one? We're all doing the same problem. Come on, it's fun to try to play with it. Okay, Catherine, why don't you do this top right square? And Diana, why don't you do this bottom left square? Oh, Helen's actually dividing it up. So one of you is going to show area, one of you is going to show traditional, another one showing area. Uh, The question, how do I do that? Are you talking about writing on the whiteboard? If that's what your question means, on the left here to the white screen are these little icons that have a little finger pointing to them. If you go to the one with the square and you click on the one with the open square, it'll allow you to make a square. If you go to where the big A is, that allows you to actually type in numbers. If you go up to the pen or pencil, it allows you to write in numbers. And so they're building it from there. Does that help? You could play it, if you'd like, in the bottom right-hand corner and give something a whirl down here. It doesn't even have to be what we're working on. Very good, Mr. Diaz. So he broke up his 10 and 13 into 10 and 4, very nice, and 10 and 3. I'm very impressed that you're writing, Mr. Diaz, because it's very hard to do legibly. Helen just asked if anyone would like to finish the lower right-hand corner. She started a problem there and wanted to know if anyone wanted to finish that. Helen has a question for the problem on the lower right-hand corner that has 10 plus 3 times 10 plus 4. She wants to know if anyone has seen problems written that way before. If you have, can you put a happy face? And if you haven't, put a sad face. So a little of both. We have a little of both, Helen. Okay, well, that bottom right-hand box is being completed. Helen would like, okay, hold on a second. So Libby said the bottom right-hand corner is that's how they do partial products, is to break down the factors first. And Helen wants to know if anyone actually teaches it that way along with the traditional. Libby does, and her whole district does. Does anyone else teach this way in the right-hand corner here instead of the traditional? Or instead of doing a different way on partial products? Yes, okay. You review it this way, great. All right, so how about this way that Helen just typed it down below? Where she took this problem that was written more vertically and typed it out horizontally. Yes, you do that as well. Yes, this format or this way is more algebraic looking. It looks more like those properties that we looked at and such, that you could break apart numbers and such. So that would definitely work as well. And all she did was take this and do that. So she did it 2 different ways. All right, Mr. Diaz, I believe, did this top left corner. So he had 10 times 10 is 100, and 3 times 10 is 30, and 10 times 4 is 40, and 3 times 4 is 12. And then over here, he just added those all up and got 182 and gave himself a happy face for doing such a fabulous job. Very good. And then down below, I forget if this was Catherine or Pat or who did this one. Sorry, but I don't remember who I assigned it to. Diana. That's you down here. So 10 times 10 is 100, and she did the same thing that Mr. Diaz did up above and added it up instead of vertically, added it up horizontally, and still got to 182. And then over here, we had some partial products of traditional multiplication, or she actually just did traditional multiplication. So 4 times 13 is 52, and 10 times 13 is 130, and added them up, and what do we know? We always got to 182. So very good, and thank you all for volunteering. Helen said that she was just trying to keep to see if she could get a discussion going. It's hard when we don't all have speakers to have a discussion going. But I was going to go back. Keep in mind that there are other ways to break down the numbers 13 and 14, but the way it's shown really helps students make connections to traditional algorithm. And Mr. Diaz wants to know, Helen, would you FOIL that problem? Well, Helen's writing back to Mr. Diaz. We just immediately went to 10 and 4 because those are basic facts, easier than, let's say, saying, well, let me break up 14 to 7 times 7, or 7 plus 7, I'm sorry, because most kids aren't familiar with their 7 facts as they are with their 10s and their 4s. The other thing is just be aware of sloppy language here, because a lot of times people will say, well, 10 times 4 is 1 times 4 with a, and you add a 0. Well, you're not adding a 0, you're putting a 0 onto the end. And those are 2 different things. If I add 0, it's not going to change my value. If I put it onto the end, then it becomes 40. Helen's showing us right here now how she's FOILing. So she did 10 times 10, which would have gotten her 100, and then 10 times 4, which would give her 40, then 3 times 10, which would give her 30, and 3 times 12, which, 4, which would give her 12. And she would still get to 182. And she said, but it also shows how it's easier to be confused. Kids always go first outer in last, first out in outer last. They always forget what FOIL means because it's something else they have to remember. If they have this area model or even partial products, it seems to be an easier thing to remember. But once again, yes, if you have a 2 by 2 rectangle, there's no way to miss any of the facts. You know, when you actually put it out this way, as long as this was equaling 14 and this was equaling 13, you're going to get all of your facts. So, any questions? If so, raise your hand. If not, give me a happy face and we'll move on. I see happy faces. Okay. Then we are going to actually, I was going to give you a problem to work on your own, but I notice we are down to the last 2 minutes. If you would like to, I'm going to actually just add a blank sheet. I just put a blank sheet up here. If anybody wants to practice with the problem, you certainly may, if you want to try to draw the area model or figure something else. But otherwise, I'm going to just flip the sheet and then I'll come back to that. But otherwise, I just want to say thank you for coming. Once again, I'm Cynthia Rath, and my email is there in case if you need me. If you need to have a letter sent that you were on here so that you have confirmation that you've been to the training, just email me or email Jo Packham, and she will send you that letter. But I'm going to go back in case if anybody wants to play on the light screen. If you have any questions, please let me know. And otherwise, thanks for coming, and I will see you next week. I will actually be on next week also doing the division algorithm. So I look forward to seeing you all then. Have a great day. Thank you.